Okay, here we are. Today is day 15, and this challenge for day 15 is Web Attack Forensics Drone Alone. And my disclaimer as always, I'm not a cybersecurity professional. I have no experience in or with cybersecurity, so I am just like other beginners taking these challenges on, well, as a beginner. And with that being said, here we go. Today's day 15. Of course, we have our two videos associated here. We have two tasks, task 1 introduction, task 2 web attack forensics. And I do see that we're going to have some machines here today. So I'm just going to go ahead and scroll down real quick. Look at our connection card. We are going to need the attack box and our VM. So I'm going to go ahead and start the VM, target machine. Click out of those and start the attack box as well. And while that stuff is loading, I'll go ahead and start reading through task 1, introduction. So actually, let's do this. When this is loaded, I'm going to go full screen. So TBFC's Drone Scheduler Web UI is getting strange long HTTP requests containing base64 chunks. Splunk raises an alert. Apache spawned an unusual process on some endpoints. These requests cause the web server to execute shell code, which is obfuscated and hidden within the base64 payloads. So for this room, your job as the blue teamer is to triage the incident, identify compromised hosts, extract and decode the payloads, and determine the scope. We're going to use Splunk to pivot between web Apache logs and host level sysmon telemetry. And real quick, we do have our target machine here, IP, and attack box, as well as IP. Yours is probably going to be different than mine. So to follow this investigation steps, we will see the steps below. Each corresponds to a Splunk query and investigation goal. So learning objectives: detect and analyze malicious web activity through Apache access and error logs, investigate OS level attacker actions using sysmon data, identify and decode suspicious or obfuscated attacker payloads, and reconstruct the full attack chain using Splunk or blue team investigation. So of course, we're going to review the connection card, which we did here, and the questions below. And the only questions here for today is, have you started your machines and your attack box? Yes, we have. This little section here just tells us how to start the target machine and start the attack box. So while this is getting ready to load up here, let's go ahead and kick off task 2. And then what I'm also going to do is kick this into full screen. Wait for that to load. Almost there, almost there. There we go. That should adjust. There we go. And go ahead and get rid of that. And here we are, task 2, web attack forensics. Logging into Splunk. After you have started the attack box and the target machine in the previous task, allow the system about 3 minutes to fully boot, and then use Firefox on the attack box to access the Splunk dashboard at, and then this is going to be the IP provided as well as port number for me. And then we're going to use the credentials below to log in. So once we log in, once we get to the Splunk login page, this is what it should look like. And after logging in, this is what the search area should look like as well. So we're going to go ahead and actually copy this here. Come here. We'll see if it's loaded and ready to go. And I'm going to open a new tab, add that IP import, and go. Nope, not ready. So we're going to go ahead and let that load. And then I will come back once it's ready to go. Okay, here we are. We're back, and we do have the IP port number all ready to roll. Everything is loaded properly. So now we're going to go ahead and go back. We're going to grab our username, paste that in. Go back and grab our pass key, paste that in, and then we're going to sign in. And we can see it's loading here, so we'll just give that a moment. and this is what the search area should look like once we're logged in. So make sure to adjust the Splunk time range to include the time of the events. Let me just scroll down. So we see the time frame of the events right here, 10:1 through 10:26. They have a specific time range selected. So can we do that as well? Well, we can just do all time. How about that? Okay. Now we're logged in. We have our time range set. Now, as a blue teamer would explore various attack angles via Splunk, in this task, we will follow Elf Log McBlue, who uses his Splunk magic to unravel the attack path. So first and foremost, we need to detect suspicious web commands. In this first step, let's search for HTTP requests that might show malicious activity. The query below searches the web access logs for any HTTP requests that include signs of command execution attempts such as cmd.exe, PowerShell, or invoke expression. This query helps identify possible command injection attacks where the evil attacker tries to execute system commands through a vulnerable CGI script, such as hello.bat. So we're going to go ahead and copy this whole query here, drop it in here, maybe. Let's try that again. We're going to copy, paste, there we go. Now we'll paste it here. Go back. Let's search. And we have a couple events here. So we do see they have 2. We have it set for all time, so we have 4. At this step, we are primarily interested in the base 64 encoded strings, which may reveal various types of activities. Once you spot encoded PowerShell commands, decode them using base64decode.org. Let's open a new tab. Okay. And then we need to locate this base 64 encoding. So based on the results we received, let's copy the encoded PowerShell string. So I guess we could just copy this here, but let's see if we can locate it. Okay, right here and right here as well. And then come in here, paste, and then click decode. Okay, so I see THIS. So this is now mine. Mwahaha. Okay. So we did a paste and decode on base64decode.org. Now we're going to look for server-side errors or command execution in Apache error logs. But before I do that, let's see our questions. What is the reconnaissance executable file name, and what executable did the attacker attempt to run through the command injection? What executable did the attacker attempt to run through the command injection? Would that be this first one here of PowerShell.exe, since that was located? We see cmd.exe and we see PowerShell.exe with an encoding. Attempt to run through them. We'll keep pushing forward. We'll see. All right. In this stage, we will focus on inspecting web server error logs, as this would help us uncover any malicious activity. We will use the following query. So we can copy this, come back here, back in the search field, paste, search. And we see PowerShell.exe in the error as well. So this query inspects Apache error logs for signs of execution attempts or internal failures caused by malicious requests. As you can tell, we are searching for error messages with particular terms such as cmd.exe or PowerShell. So we're going to actually change the view status to raw from the dropdown above the event. Okay, right here. Right here. And now we definitely see the PowerShell.exe, PowerShell.exe, and PowerShell.exe. Ran at on the 26th at 9 p.m., 27th at 4 a.m., and 27th at 4:39. So 4:37, 4:39. This was an error. So if for a request like CGI bin hello back $CMD equal PowerShell triggers a 500 internal server error, it often means the attacker's input was processed by the server but failed during execution. Okay, so I do think that one's going to be for one of our questions down below. Checking these results helps confirm whether the attacker reached the backend or remained blocked by the web layer. So trace suspicious process creation from Apache. Let's explore Sysmon for other malicious executable files that the web server might have spawned. We will do that using the following Splunk query. So we're going to copy this one here and come back again in the search bar. And we're going to go ahead and paste. Clear out all that space. Search. Oof, that's a lot. Okay, let's go back. And it says the query focuses on process relationships from Sysmon logs, specifically when the parent process is Apache httpd.exe, and we want to change this to the table view. Let's go here. Oh, much better. Typically, Apache should only spawn worker threads, not system processes like cmd.exe or PowerShell.exe. If results show child processes, such as this followed by httpd.exe and this path followed by cmd.exe, so the parent image and the image here, it indicates a successful command injection where Apache executed a system command. The finding above is one of the strongest indicators that the web attack penetrated the operating system. That's not good. So we do see a cmd.exe and the Apache 24 bin httpd.exe. And those are the ones we needed to look for. Okay, so now we need to confirm the attacker enumeration activity. In this step, we will aim to discover what specific programs we found from various queries or previous queries. From previous queries do. Let's use the following query. I don't understand that wording. So let's come back to the search bar, double click, paste, clear out that space, search, and let's go ahead and go back and read. Query looks for command execution logs where cmd.exe ran the whoami command. Attackers often use the whoami command immediately after gaining code execution to determine which user account their malicious process is running as. Finding these events confirms the attacker's post-exploitation reconnaissance, showing that the injected command was executed on the host. Okay. So reconnaissance. What is the reconnaissance executable file name? I think that's going to be whoami.exe. Perfect. And we ran this. Now we need to identify base64 encoded PowerShell payloads. In this final step, actually, let's see here. Yes, okay. So in this final step, we will work to find all successfully encoded commands. To search for encoded strings, we can use the following Splunk query. Let's go ahead and copy this. This query detects PowerShell commands containing encoded command or base64 text, a common technique attackers use to hide their real commands. If our defenses are correctly configured, this query should return no results, meaning the encoded payload, such as mwahaha message, never ran. If results do appear, you can decode the base64 commands to inspect the attacker's true event. And I see no events here, so I'm assuming, you know what they say about assuming, you're right 100% of the time. Search. Yes, no results. So I guess our defenses are set up well. Okay, if results appear, which they did not, now what executable did the attacker attempt to run through the command injection? What executable? Well, the only executables I've seen is who am I, which is right here, and cmd.exe, which that's not going to fit there, as well as we ran, what was it? Not this first one. This second one here. This is what I think they attempted to run, is PowerShell. So we're going to do PowerShell.exe. Yes. Okay, that's it. So let's just blow through all this and close. Now we need to terminate this machine. Close that out. Close that out. And let's terminate this machine. Okay, that's going to be it for day 15.